Audio Jungle. Audio Jungle.
All right. So, like last class, we had seen uniform flow. Recap, no? Uniform flow we have seen both parallel to x-axis and parallel to y-axis. Parallel to x-axis and parallel to y-axis, right? Both we have seen last lecture. Fine. Then we had seen source. We had seen sink. And for all the cases, what we had calculated, stream function and potential function. And what we had done one more thing, that was the flow pattern. So this thing we had done in last class. We had done this thing, okay, and we had calculated equation of stream function, equation of potential function, and we had seen the flow pattern also. Now we are going to talk about vortex flow. Vortex flow, okay. Called, one is called free vortex, another is called forced vortex or force vortex. Free vortex and force vortex. All right, fine. Now very important, here we are talking about the ideal flow, okay. We are talking about ideal flow. So free vortex is the ideal flow, or you can say it is the potential flow, or you can say or irrotational flow, okay. Free vortex, by the word only you can understand, external torque will be zero because it is free, okay. External torque will be zero. Force vortex, it is not like you are not able, it is rotational basically, it is not irrotational. It is not irrotational flow. Basically, force vortex is what? Rotational flow. Hence, external torque will not be zero because forcibly it is going to rotate. Okay, so comes like a rotational and irrotational. Hope you understood this. All right. Now, now, so what is our concentration? Our concentration is only free vortex. We are not going to discuss force vortex. Here I will explain force vortex, but it is not a part of our elementary flow. Okay, it is not a part of ideal flow, but just for your knowledge purpose, in 2 3 lines I will tell you what is the Bose vertex. Our concentration is what on free vertex flow, because free vertex flow is the irrotational flow. Already steady and incompressible is there. Okay, but if it is irrotational, then it will be a potential flow, ideal flow. And obviously it is free vertex. Free means what? There is no external force or there is no external torque. No? Free means what? Free means no external force, no external torque. Okay. So, so that's the reason we have only free vertex flow. Okay. If I say vertex flow, means immediately it should come in your mind. It is free vertex. Okay. It is free vertex. So what is the free vertex now? So free vertex is what? It is a circulatory flow. It is a circulatory flow of of a fluid. Okay, such that its streamline are concentric circle. Okay, all right. Concentric circle means what? If I say, suppose this is the center part, this is the center. Okay, I must say it is O. So concentric circle means for each circle that center will be same. If fluid will particles will rotate about one axis, so it will form one circle. So this is called vortex. Free vortex flow. Okay, this is the one thing. Free vortex flow, that it is forming a circulatory flow, and it is a concentric for the fluid. Streamlines are concentric, so these are the streamlines. Okay, streamlines. Huh? These are streamlines. Okay. Anyway, now we need to define what is the free vertex here. So free vertex. Okay. I must say this is the center part. Here you say this is O, and concentric circle. So two circles I am considering. Okay. There are two circles we have, and this is the center. So it is now concentric circle. For this circulatory flow or vortex flow, I am considering because these are the streamlines. Okay, these are what? Streamline. Basically this is the circle. There should not be any confusion. I am not going to draw the complete circle. This is one circle. So I have taken the partial part only. Okay, so this is basically circle, and Suppose mass of fluid, I can say this is what? This is what? A, B, C, D. So in this section A, B, C, D, the mass of fluid is what? M. Okay. And here the velocity is what? B. And the radius is what? R. Mass of fluid in A, B, C, D, A. V, velocity of fluid. Okay. Now R, the radius. Okay. Fine. If you talk about the momentum of fluid, it is what? Mass into velocity. I can denote this momentum, which is nothing but mass into velocity. Okay. Next, I can write moment of momentum. So momentum is mv and it is moment, so just multiplied by the perpendicular distance, which is the radius. So mvr is what? Moment of momentum. It is called moment of momentum. Sometimes it is also called rotational moment. What it is called? Or this is also called rotational moment. Okay. Now rotational momentum, sir. Okay, two types of momentum, linear and rotational. So because here particles that bunch, you can say A, B, C, D. So inside there are many particles, so they are rotating about the center O. Okay. So obviously whatever two types of momentum I told you, linear momentum and rotational. So here we'll talk about rotational momentum because particles are rotating about one point. So moment of momentum is nothing but mvr. Now rate of change of moment of momentum. This rotational momentum also called angular momentum. Okay, so there should not be any confusion. Rate of change of momentum or rate of change of angular momentum. So what is the rate of change of angular momentum? First, moment of momentum is nothing but moment of fluids is nothing but p, which is mass into velocity. If I say moment of momentum, then what will be the moment of momentum? I must say it is moment of momentum. You can say this is nothing but capital M. Okay, so that there should not be any problem. No? Moment of momentum. Now rate of change of angular momentum. So rate means per unit time, derivative with respect to time, or what is capital M? It is mvr. Yes or no? Check what is capital M. I said it is mvr, moment of momentum. So if I'm saying rate of change, rate means what? Time. Rate is what? Derivative with respect to time. So dou by dou t m. Now dou by dou t m, mass is constant, so mass you can take outside. Radius is also constant for the particles, so it is you can say dou v by dou t mr. What is dou v by dou t? It is acceleration, no? A for acceleration. What is that? Dou v by dou t. Now, so you got dou by dou t of m or dou by dou t of mbr, mass into acceleration into r. What is the mass into acceleration? It is force into r. What is the force into r? It is torque. So basically, rate of change of angular momentum, okay, rate of change of angular momentum is nothing but torque. Yes or no? So up to I think it is clear. Okay. If any doubt, you can write message in comment box, so I will reply, or directly also you can ask, no problem. Now, so we got torque is equal to, what is it? This value. That means rate of change of angular momentum. Okay, and this torque is nothing but obviously external torque. Huh? So we know, because torque itself, it is a external. Huh? Yes or no? So like for the, I told you, for the external torque for the free vertex, for free vertex, what will be the external torque? It will be 0, right? For free vertex, this is the conclusion. Yes or no? MDR is equal to constant. This is the basically conclusion for the free vertex. All right. So I can say C, mass is constant, so we can say VR is equal to constant. And this VR is what? It is tangential velocity or not? Check how you would say it is tangential velocity, because it is circular motion, and whatever the velocity here I had given, actually it is tangential velocity, or you can say circular velocity. Okay. Yes or no? Fine. Now, so V theta R is constant, or you can say V theta is what? Inversely proportional to R. Okay. Once you remove the constant, that one constant will come which is nothing but k, you can say 1 by r for vertex, or you can say circulatory motion, not flow, better to say motion. K will be what? Circulation upon 2 pi. Okay, done. So this tangential velocity v theta is what? Circulation upon, and this is not new for you. When I explain circulation, when I explained circulation, what was the circulation? Huh? It was what? For the closed circle, V will be V theta, and what will be the ds? Ds will be 2 pi r, that is the circumference of the circle. Okay, if ds you take elemental length for this circle will be ds. If you integrate this, ds for the full circle, then it is the circumference, which is nothing but 2 pi r. So here also you will get circulation. This I explain in circulation. When I explain circulation, that time I had given this formula and I told you this is very important. See the same result you are getting here. Why you are getting same result? Because it is also free vertex, so circulation will come. Okay, it is free vertex, means irrotational flow. Okay, hence formula for the tangential velocity will be same, just like for the circulation. Always remember guys, one more thing very important. For the free vertex, for the free vertex, for the free vertex, here one thing I need to mention. Bernoulli equation valid, okay, but in case of the force, Bernoulli equation cannot apply for force vertex, okay, but for the free vertex Bernoulli equation is valid, you can apply. Okay, you always remember, this is very important. They can ask question, they can ask question to you. Okay, so be prepared for it. All right, so I'm believing whatever I'm explaining everyone getting. Still you have any doubt, you can ask. Fine, now our task is what? Once you got tangential velocity, so now just like for the source flow, for the source flow there was only radial velocity, there was no tangential velocity, but for free vertex, but for the free vertex flow, okay, tell me, but for the free vertex flow, v theta is equal to circulation upon 2 pi r. So for free vertex, what will be the radial velocity? Radial velocity will be 0. And what about tangential velocity? That will not be. but in source flow it was just reverse. In source flow radial velocity was not zero and tangential velocity was zero. So but for free vortex flow it is just reverse, always remember. So now our concentration is what? This tangential velocity, what is the formula? Circulation upon 2 pi r. Now just we want to write the equation of stream function for free vortex. What is the tangential velocity formula for the free vortex, if you remember? What is the formula for the tangential velocity in terms of in terms of a stream function? It was, if you remember, v theta was minus, if you remember it, in polar form v theta was minus dou psi by dou r. Yes or no? If you remember it, no? So what we have, v theta is what? Circulation upon 2 pi r. This formula you should remember. I had given polar form to match it. Okay. So now we got minus dou psi by dou r, which is nothing but tangential velocity, which is also nothing but circulation upon 2 pi r. What will be the psi? So it will be circulation upon 2 pi with minus sign. Okay. It is ln r. Yes or no? This is the equation of stream function. Similarly, we can write equation of potential function. So what was the formula, if you remember? In terms of potential function, what was the formula? If you remember, it was tangential component only. I am not interested in radial because radial is useless for the free vortex. So v theta was dou phi by dou r, dou phi by 1 by r. No, check your formula notes if you have. And what is the v theta? It is circulation upon 2 pi r. What will be the derivation if you do? r you can say it is cancel out. What will be the phi? Phi will be check circulation upon 2 pi into theta. Yes or no? Check it there. So directly I am writing result because by seeing only you can say okay, this is the integration, right? So due to lack of time, each and every steps I cannot write. I have to skip few steps so that we can complete. No, fine. So this is the equation of potential function, and this is the equation of stream function. Now for the stream function, if you check, it is ln r. What do you mean by ln r? What do you mean by ln r? Ln r is just, it is just ln r. I explained that the ln r, r in polar form is nothing but x square plus y square, or r square is equal to x square plus y square. This is what? Equation of circle. Yes or no? So stream function will give the concentric circle. That will be the circle part. It is negative sign, so don't bother about negative sign. You just make the direction anti-clockwise. No? Because stream function you are getting minus circulation upon 2 pi, so don't worry about it. There is like If you are getting negative signs, you just make it in anti-clockwise. That is the one thing you can do. Otherwise, for the magnitude there is no problem. Okay, for understanding only, if you are considering circulation, psi is minus circulation upon 2 pi by minus circulation upon 2 pi lnr, so that minus you can say whatever the circulation you will have or streamline you will show, and that vortex flow if you show through the streamline, so it will be anti-clockwise. That's the mean of it, that's all. Okay, and sir, here phi is equal to circulation upon 2 pi theta. If you change theta 1, so phi 1 theta you can take 30 degree, because circulation upon 2 pi is constant, so theta you take 30 degree. Then in radian you have to write, okay, theta in radian. So it is like pi by 6, pi by 45, pi by 2. Okay, in radian you have to keep here this theta value, so phi value will get different value. Now, so I think now need to draw the flow pattern for this. If you will draw the flow pattern for this, it's very easy. Check. I'll show you that this is center part. Okay, just say this is the center part, because it is now forming a concentric circle. So this is what concentric circle. So these are the streamlines. Okay, these are the streamlines, and I can make it anti-clockwise. Yes or no? Fine. And where is the potential function? So it is just perpendicular to the streamline. So this is what? So this is what? Pi 1 circulation upon 2 pi, theta 1, pi 2 circulation upon 2 pi, theta 2. Similarly, pi 3, pi 4, pi 5, pi 6. Understood or not? This is what? Pi 7, pi 8. Similarly, that inside part will be what? It is the psi 1. You say this is what? Psi 1. Huh? What is it? Circulation upon 2 pi ln r1. Similarly, this is what? Psi 2. This is what? Psi 3. So here these are the streamlines, and this part basically these are the equipotential line. I hope you all understood this, right? So this is the part of the basically what it is called uh, vortex flow. Okay, force vortex I told you not required, but in short I will explain you here.